try to load this one. Data wrangling, prac week 3A. Okay. If you check the structure of this lab session, we have 3 parts. The first part is I will show you how we can scrap data from a web service. And suppose that web service provides some kind of API for us to load and for us to check the content that's in the related part. And we'll see how we can call that API and how can we pass the generated file and put it into a data frame. Second part is we will try to extract a table from a web page. And for example, Wikipedia, we have several pages contains a table. How can we pull those kind of data into a table? The third one is passing the XML file and using a package called a Beautiful Soup. And I will go through the first 2 with you because the third one is quite straightforward. And let me have a look at the first one. This part is mainly try to use a service as in Canada. Canada, they have a website like this, historical climate data, and then they have many different kind of there's a historical information. You can just search, say for any place, and you want to show a particular specified month for that data. You can see what kind of data they provided as for to outside. So that is the web service there. But this website does provide an API, and when we put URL inquiry with the format just like this, and we are going to specify what is the year or what is the month, and then they will be able to generate the CSV file for us to for us to check and for us to do further analysis. So I just run this one, authorized by Google, but I will run it anyway. So here we import a pandas package, and we just specify a URL pattern like this. Inside of it, there are several parameters we can specify, say which year we want and which month we want. So suppose I want to use this template by specify the month to be 3 and the year to be 2012, and then we'll see what is the string we get. So this URL is a string, this string is the content like this, and then I can try to click this one to see what kind of data they generate. So if you have a look at this one gives us a CSV file, and then you can save it, or you don't really need to save it. But my suggestion is, in the real situation, you should open this file and then check the structure of this data. And once we have the structure available, you will, based on your understanding of this file, and then to see what is the CSV structure and what is the data that you get from there. I try to open that. Say, suppose I want to use Visual Studio to open it. Okay, I open this file. It's a CSV file. Okay, so this is a CSV file. There are many lines, but I can see that the first line is the table's head, and they have many different kind of information. That's a column. Firstly, it's a longitude and the latitude and the station name and many other information. They have date and time and the year, month, and many different kind of information. So this is the file generated from that web service. What we try to do is we want to extract some kind of information from this file and then put them into a table such that the pandas and then Python, we can further process it. So let's have a look. So this is URL. We haven't done. That's why we click and download it, but the program doesn't do anything by now. What we try to do is we investigate this information. We found that there's no meta information, and then the first one is the head. So we will try to use a pandas, a function called a CSV file, and then this is the URL. We'll skip 0 lines. Previously, that is we need to skip 15 lines or 15 rows because original version of this service that provide us many meta information, but now we don't need to do that much skipping. So skipping row is 0, and then we will use the date time, this column, this one, as our row ID or index row, and then we pass it, and then the encoding we specify as Latin, and we just click and run. Okay, and it seems nothing happened, but we can show what we have for here. So you can see here, what do we have get from this CSV file actually from the URL is a table put into pandas, and then they have many different columns, and then they also have the many different rows. We show the basic, that is a structure that's used in the head, that they will display the 5 rows for us, and we use the date and time, this column, as the index, that's a column. So that is the information. Inside of the data, we can also see there are some variables or attributes. They have lower value or not available value, and then we want to remove those kind of things. We see if any kind of column that contains none or low value, we are going to drop them. So we do next thing, drop an A, and any value have an A, they drop there. And then we show what do we have next. So you can see this dew point temperature, this one, because they're non-value, so it's removed. And then, so basically from this one dew point and the next one they are removed, and then anything else like this one, wind speed flag just removed, and then the other that's a column which is a long value, they're all removed. So that is the dropping operation, such that all of these kind of data we generated, and then they have value inside of it. And then we can also do something like, say, drop some of the column, because here the date time that contains year, month, and date and time. So these 4 columns, we don't want them. We want to drop them, remove them, and we can do this one. Okay, so after we drop it, we can see this column removed. So we can use this kind of, say, operation on a table, such that we can select a particular interested column or select a particular set of records for us to do further analysis. This is basic, that's an operation then, but then we can write it as a general function. We define a Python function. Suppose the function name called as download weather month. I will specify the year and the month, and then inside of that pretty much that's as default. But here, make sure that this is skip row is 0, and then we define the function. Suppose now what I want to get is, I suppose, last month weather information to see what we can have. Okay, we can see this is the information from that website for last month, and in different kind of stations. That's what is the station ID and what is the climate, that is the ID number. And then I can just collect the data for a whole year, for every month. Say for 2012, I want to collect everything from the first month to December, and then I can just put all of the result into a list. And then once we have the result in the list, I can just use pandas concat, just merge all of the result, just union the sets together, get the whole year's data. Okay, and I can show the information here, and they show me what is the data type of them. It's a data frame, and then what are those? There's a columns there, and then also that is what the data type for each of them, and what is the size of these pandas. And I can save this data structure to a particular file, and then you can see, once you save in the file, you can see in the Google Drive, you will be able to see this one. That is the file that you saved. Suppose I want to save it as say 2020, suppose, just like this, or 12. Okay, and then list it again. There'll be one more file that's generated, and then you can download it, and then you can also further process this kind of file if you want. After we have the file generated, the remaining part, that is, you use different kind of data visualization to show the content and show the structure of them. More detailed, there's a data visualization content will be covered. That's in the other, that's a notebook. For now, just you can go through them and to understand that how to do this kind of very basic data visualization. And if you are using that's IPython notebook, and they may pop up a new window, but you want to show that everything that's inside of the current notebook, and then you have to specify whether this plotting is in line or not. So this is another visualization. So just the other part, I will not click through it, but I think you can just run and then to see what is the result they generated. So that is the first part. This part is about how to crawl data from a web service. Suppose that a web service provide you provide you a file for you to download, and then that's a very basic one. So let's have a look at the second part. The second part is we want to extract a data from a web page. So let's have a look at this one, Wikipedia page. Okay, so this is a web page. Suppose on the Wikipedia page, there will be many different tables. Some are already specified, already drawn for you. Okay, put it there for you. And then all of those kind of, say, data, they're just a HTML file. So is it possible for you to put this data into a pandas file? So that is the requirement. Of course, the simplest method, or we cannot say simplest method, just say the most ad hoc method is you just copy and paste, and from there you can change it into CSV and load the CSV. That's one way to do it. But because the web page is already like this, is it possible for you to automatically extract the data from the web page and then put them or save them into a pandas data frame, a table? So let's have a look how we can do this. We need to use two packages. One is URL lib library, and the other one is Beautiful Soup. And then I just import them. The web page is a wiki page. That's a URL of it. And then we try to open it, and then we'll see whether we can read them. And we use Beautiful Soup, specify the file format is following XML, that's LXML format, and then we load them into Soup, and then we use Prettify to display them properly. So if you have a look, this is the source code in this output. This is the source code for that web page, and the content is very similar to this function. Say if you can see the view page source, that is what we have. Okay, so that is what we have. So in Python, I just click this, close this one. Okay, we can show that is a web page source code using the soup, but then the question is, can we extract the content of them? And we can just say extract the title of this page. So this is a title, State and Territory of Australia, just like this one. Okay. State and Territory of Australia. They extract the title of them, and then we want to find out the tables inside of them. We can just using the soup find all the tables, and you will see all of those kind of tables contained in this web page. They just extract the table together with the line with the information inside of that table. So that is all the tables we can. Where is it? All the tables we can extract them, and then the next question is how can we get a table, save them into pandas, and this link provide you there's some kind of say tutorial introduction how can we do this one. But if you don't want to read them, we can just directly work on this page to see what are they working on. For Wikipedia page, because all the tables has a special kind of class called a wiki table sortable. So let's have a look at this source code. Okay, so we can see here we have wiki table. Okay, this is one wiki table, and then if you search it again, this is another wiki table. That's the internal territory of Australia. Let me see. This second one. And then if you check the third one, this is external territory. And we check whether there's another one. This is another wiki table. The entities and the types. And then we may have the other, that's wiki tables. So we can find that from here. We can find that they may have many different kind of say wiki tables. Relate them, and what we want to do is we want to show you how can we save the first table into pandas. Let's have a look at the source code. First, we find out the table. The first table that made, they extract all the source code here. So here from this line to the bottom of this output, that is the table. Okay, so that is a table. Pretty much, this is the source code about quite a complex one, okay? Quite a complex table. So in the source code, we see in the source code, we'll be able to see that is pretty much this part, okay, from here to the end of it, to the end of that table. We see where is it. There are quite a number of things, but I will say you'll find out basically that corresponding to this table, just as the source HTML page for this table. And then we can use this one, print write table, to generate, to just output the HTML content of it. We know that all of those kind of table information we want to extract, they are here. And then what we need to do? First thing is we find the first row, because the first row contains a head. So we will see what are the first row. So the first row is the head, and then from it, we will be able to extract the column. That's each of the column, what are the title. And then I use this one to show that, okay. For this row, HTML table row, inside of it, how many that is head we have. And then for those kind of head, then the first one is called flag, second one called state name, and then they're called abbreviation, and then we just extract all of these things here. And please be aware that this web page, Wikipedia page, is changing, its potential will be changed in the future. So this table, they may not be as this, okay, 1 year later. Just like 1 year ago, we didn't have the governor, we didn't have a premier. So here, based on the content, we are going to check or create a source code. For each of the column, we are going to create a list, say flag and state and each of these one. You can type in anything. And then we are going to create, that's a list for them. And then for each of the row inside of a table, suppose this is a table, okay, this is a table. And then for each of the row in the table, we are going to find out and get the content of them. And then this is content of each of the row. And if the length of that cell, that row is larger than, the cell is larger than 0, that means they have contents of them. And then what we are going to do is we see at which location it is the attribute we are looking for. So we know that the first one, let me just output something first. Okay, suppose I just run it like this. So I've run it like this first. If I run it, the cells, the row, the first row they have is this row. Basically, is the whole row. This is a row. Okay. And then for this row, that's the content of it, and that's the first cell of it. And for the first cell, you can see it contains, basically, it contains, whether it contains, that's any kind of, say, what is the information it contains there. Okay, so that is the, that is the information for that cell. And then because they make the results very messy, so we'll just delete this one. Okay, and then based on the checkup, we found that the first column corresponding to the flag, and then the tricky thing is here, the 8th column corresponding to governor. But then what is next? Or next one is premier. It's not column 9, but actually in column 10. And how can we find that? Suppose now I want to print out first cells. This 8, cells 8. Okay, sorry. Okay, and then I just say column 8 is like this, and then I want to show what is column 9. Column 9 is this. 9. We'll see that what is column 8 and what is column 9. Run it again. So we can see for each of the rows we are going to show. For the column 8 is this one. This seems like a name. Okay, that's a governor's name. And column 9, nothing there. It's a color, background color. So that is the cell. If you check the table, it's column 8. This one empty. It's no text there, just a color. And then this is premier information. So that's a column 10. So this is column 9 is there. And then if it display column 10. Okay, column 8 is a name, column 9 is a background color, column 10 is another name. So based on this observation and also data manipulation and data as a wrangling requires us to check those kind of web information. This is based on the real situation and adjust the source code. So I just make sure that, okay, for each of the column, we put all of the information into the list and assign the content in the list. And finally, we display the table. So you can see here, For each of the column, we have the information. Of course, the flag, because flag here, it was just a picture, so I didn't extract a picture here. I just found that nothing as a text there. So this is the table, how we can extract any kind of tables from a HTML page. And if you have very big and very long as a table, you can also use the same method to extract them. So that's pretty much the thing I want to demonstrate for this lab session. And then for the other notebooks, even this part 3, I think it's quite straightforward. You can just read and understand and run them to get a feeling of them. And as for the CSV file, JSON file, you can also try to go through them, because CSV file is quite popular in data science, especially for the training purpose, like assignments part. And then for the JSON file, is also a simplified version of XML, and then you can also see that it's how we can use them to represent the data. And if you want to do more complex one, Excel file or XML file, and you can just go through 2 optional lab sessions. And then I hope you will have time to play with all of those kind of lab session notebooks and get a good understanding of this material. Thank you.